All right. Section 5, distributive property. That's a tongue twister. Distributive property. Let's go. First thing we're going to go on is terms. So a term is a number, variable, product, or quotient, a number, or variables. English, that means they're going to be separated by a plus or a minus. So it would look like this. So I have 3 terms here. So I have 2 terms on the left, 1 term on the right. So term, separated by a plus. This could be a minus. This could be a minus. Doesn't matter, plus or minus. If they're multiplied together, yeah, those are terms. So the distributive property, hopefully you guys remember this one. For any numbers a, b, and c, if I have a and then parentheses b plus c, I will distribute, and I like to do this whole arrow thing, multiply, multiply, so that would turn into a times b and then a times c with the addition symbol in there. If the addition's here, it stays here. It could be backwards as well, so we'll do the one down here. C to a, so I'd go a to b, and then a to c would be b times a minus c times a. So you just kind of do those little arrows like that. That's the easiest way to do it. In numbers wise, I'd multiply 3 times 2 plus 3 times 5. So 3 times 2, 3 times 5. Most of the time we skip this step, but if you need to write it out, please do. So usually you go 3 times 2 is 6, and 3 plus 3 times 5 is 15. And then I would add these two together to 21. That's how I would find that. Another way you could do that, if you've got the numbers inside of here, you could just go 2 plus 5 is 7. 3 times 7 is 21. Either way works. And then here's just one with some negative numbers there. So when you multiply 4 times 7, it comes out to a negative number. Or you could just do the subtraction inside of here and multiply them, done. Okay, like terms. These contains the same variable with corresponding variables having the same power. So in this case here, 3a squared and 5a squared, the a squared and the a squared are like terms because they have the same corresponding variables. So I can add those together, these like terms. I could turn that into, I don't think I put this under here, I could go make that 8a squareds plus 2a. Yeah, because those are unlike terms, that means I can't add them together. So simplest form is when a term is replaced by an equivalent expression. So that's where we were saying you could add together the two, you could combine like terms. So when terms are replaced by a like term, so having no like terms or parentheses is when is it in simplest form. So an equivalent expression, whoops, that should have been in front of there. Oh well. So 5n plus 7n equals 7n are equivalent because they denote the same number. Because I could take 5n and 7n and add them together to 12n. 12n. That's by substitution, which we did yesterday. Because I substitute 12 n in for 5n plus 7n. Coefficients. So that's a numerical factor of the term. So in 7xy, the coefficient is 15. And for 3y over 2y squared over 4, the coefficient is 3 over 4. So we ignore the variables in whatever capacity, because that could also be just like 3x. The coefficient, we'll just abbreviate that, would be 3. All right, so let's see what this looks like in some homework problems. So Julia walks 5 days a week. She walks at a fast rate for 7 minutes and then cools down for 2 minutes. So we can write that as she goes 5 days a week, 7 minutes, and 2 minutes. Using the distributive property, evaluate the total number of minutes she walks per week, it looks like. So we distribute out 5 times 7, 5 times 2. We then multiply those out. 5 times 7 is 35. 5 times 2 is 10. And then you add those together would be 45. So we can say she walks for 45 minutes each week. All right, pause this, give it a shot. All right, so Suzanne walks to school and home from school 5 days a week. She walks to school in 15 minutes and then walks home in 10 minutes. Apparently, she's excited to get home after school more so than walking to school. So either she's not happy to go to school. Anyways, moving on. Rewrite 5 times 15 and plus 10. So use the distributive property. That means we're actually going to have to multiply out. And then evaluate the total number of minutes Suzanne spends walking to and from school. So I'm going to rewrite this out, 5 and then 15 plus 10. So I would distribute, so 5 times 15 plus 5 times 10. 5 times 15 is 75, plus 5 times 10 is 50. Add those together. It's going to be 125. So 5 times 10, 5 times 10, 125 would be C. All right, this one says use mental math. Yay! To use the distributive property to find 12 times 82. So if we took 12 times 82, we could take 12 times 80 plus 2. So use the distributive property to put those out. Now I can think, multiply in my head, supposedly. 12 times 80 is 960, and 12 times 2 is 24. Put those together, gives me 984. Answer would be 984. Pause this one, use the distributive property, not just your calculator. Go. All right, so use the distributive property to find 6 times 54. They're wanting us to go 6 times 50 and then plus 6 times 4. So 6 times 4 is 24. 6 times 50 would be 300. So that'd be 324. So those are the steps they want you to do. I'm sure they wanted you to check that by doing it in your calculator, which is what I'm expecting most of you to do. So hopefully you actually did it the way they wanted. All right, example 3, rewrite 12 and then y plus 3 using the distributive property and then simplify, which means take out the parentheses or like terms. So first we're going to distribute by multiplying across 12 times y, 12 times 3. Now we're going to multiply those out, 12y plus 36. Oh, well, I would have just done 36 here. 36, and then put these together, 12y, and then call that my answer. But that's okay. All right, rewrite this using the distributive property and then simplify. So first we're going to distribute by multiplying 1, 2, 3. So 4 times y squared, 4 times 8y, 4 times 2. We're then going to multiply these all out. 4y, 4 times 8 is 32, keep the y. 4 times 2 is 8. So then I'd make that my answer right there. All right, let's try this one, pause it, give it a shot, and go. All right, so I would just multiply 6 times x and 6 minus 24. So it's going to be a positive times a negative will be a negative. And then 24 would go here. So 6x minus 24. Simplify this out. All right, so I'm going to multiply 3 times x squared, which would give me 3x squared. 3 times 2x, positive, plus, would be 3 times 2 is 6, keep the x squared. I hate it when it does that. 3 minus 5x would be my next multiplication. So 3 positive times a negative is going to be a negative. 3 times 5 is 15, keep the x. And then 3 times 7, both are positive, is going to be plus 21. All right, combine like terms. All right, simplify 17a plus 21a. All right, so the book says to use the distributive property to pull the a out. and then add 17 plus 21, should be 38 A's, and that would be your answer. I would actually just think in my head, if I have 17 A's and I add 21 A's to that, then now 17 plus 21, keep the A. Simplify this one, 12b squared minus 8b squared plus 6b. So book says to pull out the b squared for the like terms, and then add 12 plus 8 is going to be 20. 20b squared, can't do anything else. There's no like terms, there's no parentheses. I'm done. Pause this one, give it a shot. Right, so the book's going to want us to distribute it out, so we're going to pull the x out, x, and then 14 minus 9 would go out to 5. 5 times x would turn into 5x. Notice we're adding and subtracting. If we were multiplying, then we'd multiply x and x together to get x squared, but in this case it's going to be 5x. We're going to keep the same term there. All right, simplify this one. All right, so 6n squared plus 7n plus 8n. Well, if I have 7n's and 8n's, that's going to be 15n's. So 6n squared plus 15n is going to be A.